Assalamualaikum to Professor Madya, TS Dr. Suraya Hani binti Adnan. We are students from Structure Analysis and Design from Section 3 and we are going to present our project. We consist of 5 members in the group, which is the number one is me, Ahmad Syamil bin Kamaruzaman. Then we have Daniel bin Mustafa, Nur Syahira binti Muhammad Zulkafli, Nur Liana binti Jaafar, and the last one is Tengku Muhammad Akmal bin Tengku Yusof. So I will pass this slide to the first presenter.
Hai, Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. My name is Daniel Mustafa. So today I will present about literature review for BIM. Okay, what is BIM? A BIM is a structural element that primarily resists loads applied literally to the BIM axis. Its mode of deflection is primarily by bending the loads applied to the beam results in reaction force at the beam support points. The total effect of all the forces acting on the beam is to produce shear force and bending moments within the beam that in turn induce internal stresses, strain, and deflection of the beam. The beam are characterized by their manner of support, profile, shape of cross-section, length, and material. Okay, next we go to the simply supported beam. A simply supported beam is a type of beam that has pin support at one end and roller support at the other end. Depending on the load applied it undergoes shearing and bending. It is the one of the simplest structural elements and existent. The following image below. So the following image below illustrates a simply supported beam. So we can see the example of simply supported beam. Okay, next, the continuous beam. So a continuous beam has more than two support distributed throughout its length. This beam is similar to simply supported beam except more than two support is used on it. So it can be understood after we see this image below, and this is some example to understand about the continuous beam. Okay, that's all for me. Thank you.
Assalamualaikum. My name is Ahmad Syamil bin Kamaruzaman and I will present with the title of slab. So before we go into the calculation of the slab, we have to know what is slab. So slab is the one of important structure element that are made of concrete, and the shape of the slab is commonly flat horizontal surfaces such as the floors and the ceiling. So the slab is commonly is supported by the beams and the columns, and slab also is fabricated off-site or maybe can be poured in situ. So there are many categories of loading on slab. As for this example, we have number one is the dead load, then we have the live load, then we have the floor finish load. The number four we have service and ceiling load, and the last one is the earthquake load. So what is one-way slab? So one-way slab is commonly the slab that being supported by the beams on the two opposite side, and the ratio of the longer span to the shorter span is equal or more than 2. So this one-way slab it can bend in one direction only, and that is what it being called one-way slab. And there are huge difference in the length that make the load not be transferred to the shorter beam. And the example of the one-way slab, as you can see, is the cantilever slab. Okay, this is the calculation of the one-way slab. So for the first one is the specification. So for this slab, the long span is 5.5 meter. The short span, which is the LX, is 2.6 meter. The permanent load that we get is GK, which is 1.0 kilonewton per meter, and the variable load is QK, which is 1.5 kilonewton per meter. So the design life of this slab is 50 years, and the fire resistance is R90. Then the exposure classes is X61. And the strength of the concrete, which is the FCK, is 30, and the strength of the steel, FYK, is 500 Newton per millimeter square, and the weight of the concrete is 25 kilonewton per millimeter cube. So the diameter of bar that we will be using is 10 millimeter, and the slab thickness H is 150. So we go to the durability, fire, bond, and loading analysis. For the C main B, we get the 10 millimeter, and C main door we get the 15 millimeter. The fire resistance, which is R90, that will be referring to the Eurocode table, and we get the value of 30 millimeter. And the C main fire, which is we get from the 30 minus 10, which is the diameter of the bar, divided by 2, so we get the 25 millimeter for the C main fire. And for the C node, which is the luminous cover, we get the 35 in millimeter, and the slab self weight that we get is 3.75 kilonewton per meter square. And the permanent load, which is we excluding the self weight of the slab, which is we get 1.0, which the GK is 4.75, and the QK is 1.5. So with this formula, 1.35 GK plus 1.5 QK, and we insert all the value in this formula, then we get the WD, which is 8.7 kN per meter square. But the WD is equal to ND, which is ND is times by the 1 meter, and we get 8.7 kilonewton per meter. And this is the shear force diagram and the bending moment diagram for our one-way slab. So the shear force with this formula WDL over 2, and we get 10.14 kilonewton. And for the bending moment, we get from this formula, which is M equal to WDL square over 8, and then we get 51.41 kilonewton meter. And we're going to the main reinforcement. For the effective depth, we get from the formula H minus C norm minus diameter of bar over 2. When we insert the value in this formula, then we get the effective depth, which is the D is 110 millimeter. So the design of the bending moment, which is MED, is 51.41, which is we get from the bending moment value. And we go for the K, which is the formula is MED slash over BD square and times by the FCK. And after we insert the value in the formula, then we get the 0.141, which is the value is less from the K bar, which is 0.167. So the compression reinforcement is not required in this project. And we're going to the Z and also AS, and the main bar that we get is H10 50 and in bracket 1571 millimeter square per meter. And for the minimum and the maximum reinforcement area, which is the AS min, and we get from this formula. After we insert the value in the formula, then we get the final answer, which is 165 millimeter square over meter. So the AS max that we get from the formula of 0.04 AC equal to 0.04 BH. And after we insert the value in this formula, we get the last answer, which is 6,000. And for the secondary bar, which is after calculate and referring the table, we got the H10 100 and in bracket 785 millimeter square per meter. And next we go to the shear reinforcement. For the shear reinforcement, the design shear force, which is VED, is 0.114, and the design shear resistance K, with the help of this formula, after we insert in this the value in this formula, then we get the K, which is 1.91, is lower than 2.0. And after we calculate the rho 1 and the VRDC, and the VRDC, we get the 87.5 kilonewton, and the V minimum, from the formula, we calculate when insert the value in the formula, then we get the final answer, which is the 55.7 kilonewton. So the VRDC is equal to V minimum is more than VED. So the result is acceptable and it is okay. Okay, for the next, we go to the deflection. In this deflection part, as the percentage of the required tension reinforcement, which is rho, is the AS required over BD, which is the 1131 over 110000, and the final answer that we got is 0.0103. And for the reference reinforcement ratio, after we calculate with this formula, and the final result that we get is 0.0055, and the percentage of the required compression reinforcement that we get is AS prime, required over BD, and for the final answer that we get is 0.00. And for the factor for the structural system K, which is 1.0 rho, is less than rho 0. So for the LD, after we calculate with this formula and we insert the value in the formula, the final result that we get is 19.4. And for the modification factor for span that less than 7 meter is 1.0, and for the modification factor for steel area provided is from the formula of AS provided over AS required, which is the final answer that we got is 1.40, which is more than 1.5. Sorry, which is less than 1.5. And therefore, for the allowable span effective depth ratio, which is the LD allowable, and from the formula, the answer that we get is 27.16, and the last one is the actual span effective depth, which is the LD actual, and we get the answer, which is 23.64, which is the value is acceptable and allowable, and it is okay in this calculation. And for the next one, we go to the cracking, which is the H. From the first that we calculate, we get the 150 mm, and the main bar we calculate for the S-max slab, which is 3H or 400, which is we get the 450 is more than 400, and the max bar spacing is 50 mm. And the secondary bar we calculate for the X-max slab by using the formula 3.5H or 450, and the answer is 450 is more than 400. So the max bar spacing is 100 mm equal to 450 mm. So the main bar and the secondary bar for the S-max slab is both is acceptable and it is okay. And the last one is the detailing. So this is the slab detail from the top and from the elevation. And for the 01 is the reinforcement for H10 50, which is the main bar, and the 02 is for the secondary bar, which is H10 equal to 100. So that's all for me, Ahmad Syamil bin Kamrul Zaman. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Naushaira binti Muhammad Zofali, and today I would like to present about two-way slab calculation. So, what is two-way slab? Two-way slab is a slab that supported by beam on all the four sides, and the load are carried by the support along with both direction. It is known as two-way slab. Okay, two-way slab dia support segala beam dalam 4 side, and also they carry support with both direction, untuk dua direction. So ia adalah two-way slab. So how to determine two-way slab? Can determine with the ratio of longer span L to shorter span B is less than 2. So kalau kita nak tahu itu one way slab ke two way slab, kita kena kira dahulu guna formula Ly bahagi Lx. So jawapan kalau kurang daripada 2 ia two way slab, tapi kalau lebih daripada 2 ia one way slab. Okay, so in two-way slab, the load will be carried in both the direction. So the main reinforcement is provided in both direction for two-way slab. Okay, so in two-way slab, load akan carry pada dua direction lah. Okay, so what is the difference between both of these slab? One-way slab, first is the beam on the two opposite sides support the slab. And two-way slab are support on all four sides by beam. Okay, one-way slab dia hanya support two opposite side, manakala two-way slab dia support four side of beam. Okay, so seterusnya, due to bending, main reinforcement is provided on shorter span. But in two-way slab, due to bending on both side, main reinforcement is provided on both side. So, dekat one-way slab, reinforce utama akan provide in a shorter span. Manakala two-way slab, bila dia bending ke dua-dua arah, besi utama akan provide dua side juga. Third, for one-way slab, main reinforcement is provided in only one direction. But in two-way slab, main reinforcement is provided in both direction. So, maksudnya dekat sini, one-way slab, reinforcement dia hanya provide satu direction saja. Tapi, in two-way slab, besi provide dua direction. Okay, and the fourth difference is one-way slab, load are carried in one direction only. But in two-way slab, load are carried in both direction. So, sama macam tadi, one-way slab, loadnya hanya satu direction. Tapi kalau two-way slab, dia akan carry dua direction. So, this is calculation two-way slab. Okay, so we design two-way slab for master bedroom. Okay, first thing we need to checking the type of slab to determine either one-way slab or two-way slab. So, Ly over Lx sama dengan kami punya Ly 5000 and Lx 4000. So, 1.25 lebih kecil daripada 2. Maka ia adalah two-way slab. So, sebelum buat kerja-kerja pengiraan yang lain, kita kena bagi specification untuk memudahkan kerja pengiraan term. So, first kita kena determine Ly, Lx. Lepas tu kena tengok GK dan QK, design life, fire resistant, exposure classes, FCK, FYK, weight of reinforced concrete, assume bar, assume diameter bar, effective length, ni semua kena refer dengan Eurocode NBS. Okay, so yang kedua adalah slab thickness. Okay, slab thickness, pertama adalah kena tahu minimum thickness for fire resistant. Okay, yang ni boleh tengok dekat BS, tengok dekat kita punya fire resistant. So, kalau R90, kita punya thickness untuk slab berapa? Okay, so kami dapat 100. Seterusnya, kena estimate thickness for deflection control, hash. So, nak cari hash, kena Lx divide by 26. So, our Lx is 4000 divided by 26. So, we get 154 mm. But, we must assume and we must try hash. So, jadi 175 yang kami pilih. So, this is durability, fire, bond and loading analysis. First thing we need to know minimum concrete cover regard to bond C min B. C min B we get from table. And then minimum concrete grade regard to durability, C min durability also on the table. And then minimum required exit distance for R90 fire resistant A also in the table. And then minimum concrete cover regard to fire. The formula is A minus diameter bar divided by 2. Okay, so we get the answer is 10. Okay, so element indices for duration adalah 10. And then nominal cover iaitu sinom. Sinom formula dia adalah C mean durability plus with allowance in design for deviation. So we get 25 mm. Okay, seterusnya we need to calculate loading and analysis. So first is slab safe wedge. Slab safe wedge is 0.175. We divide by concrete safe wedge, and then we get 4.375 kilonewton per meter square. Seterusnya we need to calculate permanent load. Okay, permanent load is 1.2, and then permanent action GK we get based on slab safe wedge we plus with permanent load, so we get 5.575 kilonewton per meter square. And then variable action QK is 1.5, and design action ND this is use the formula 1.35 GK plus 1.5 QK. So to design action 1.35 GK plus with 1.5 QK, and then 1.35 with multiply with 5.575 plus with 1.5 multiply with 1.5, and we get 9.8 for design action. So this is our moment for MSX and MSY, short span and long span. So moment for short span we get by using the formula BSX and DLX square, and we get 14.55. And long span also the same formula, and we get 8.60 kilonewton per meter. After that, we need to calculate shear. So shear, we need to calculate calculate on short span and also long span. So the formula is x1 VXX equal to BVX1 and LX. Also long span VSY equal to BVY and DLX. So our short span, the answer is 19.21 kilonewton meter per meter. And then so for the long span, the answer is 14.11 kilonewton meter per meter. So after that, we need to calculate main reinforcement. Effective depth dx is a formula h minus c norm minus 0.5 diameter bar. So we get 145 for diameter x, and then we calculate for dy. Dy is h minus c norm minus 1.5 diameter bar, and then we get 135 mm. After that, we need to calculate k. The formula of k is m over v d square fck. So the answer is 0.023. And then calculate z. The formula is d multiply with 0.5 plus square root 0.25 minus k divided by 1.134, and we get the answer is 142 mm. For AS, the formula is m divided by 0.87 FYKZ, and answer is 235 mm square. And so based on the AS, we need to determine the bar on the table that provide table reinforcement. So we get main bar H10 with 300 distance, and then this means in table 262 mm square per m. And then after short span, we need to calculate the same on long span. So K we get is 0.016, Z we get is 133, and AS we get 149 mm. So the secondary bar that we choose is H8 with a 300 distance. So in bracket 262 mm square per m. After that, we need to know the AS mean. So AS mean we get is 196, and AS max is 7000. So shear reinforcement. After that, we need to calculate shear reinforcement. Shear force VED we get is 19.6 kilonewton per meter. K is we get 2.17, but it's more than 2.0, so we need to use K equal to 2.0. After that, P1 we get is 0.02, VRDC we get is 63.80, Vmin we get is 78.60, and then we determine VRDC is equal Vmin not more than VED, so our condition is okay. And then calculate the deflection percentage of required tension reinforcement we get is 0.002, reference reinforcement ratio PO we get 0.0055, and then for percentage of required compression reinforcement AS required BD, AS required over BD we get 0, factor for structure system care we get 1.0, so rho not more than 0 less than rho O, P less than PO. So to calculate 1 over D, so we need to calculate 1 over D, and the answer that we get is 102.81. And then modification factor for span, because it's below 7 meters, so the answer, so we assume it is 1.0. And then modification factor for steel, AS prof over AS required, so we get 1.11, so it also less than 1.5. Okay, so we need to calculate allowable span effective depth ratio, I over D allowable, so we get 114.42. Actual span effective depth for ID actual we get 27.59, so it's also less than ID allowable. So after that, we need to calculate cracking. So cracking H equal to 175 mm is less than 200. And for SMAX slab for main bar, we use the formula 3H and we get 5 to 5. And the maximum bar spacing is 300 below to SMAX slab, so equal to 400. Also same for second bar, but the formula is 3.5H, so we get 613. And maximum bar spacing is 300, it's below than 450, so both of this is okay. So this is our detailing. 5 this is 5000 is our ly and 4000 is our lx. So this is our detailing for two-way slab. The reinforcement for 01 horizontal is H10 with a 300 distance, and also H8 with a 300 distance. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Tunku Muhammad Akmal bin Tunku Yusuf. So I will explain about design calculation for our project. The first one, we calculate the action on slab for safe weight. We use the value of slab thickness 0.125 and we multiply with 25 and we get the answer 3.125 kN per meter square. And the value for finishes, ceiling and services is 1 kN per meter square. And the value for permanent action GK and the value for variable action QK we get from the table Eurocode. Okay, distribution of action from slab are as follow. FS6 we use from the Ly over Ls. We use the value of the horizontal and vertical value, and the value for FS6 is 1.25 and it is below than 2, so it is a two-way slab. Same with others, FS7 and FS9, it is two-way slab also. For the action on slab, we determine that for FSC, it is two adjacent discontinuous, and the value for beta Vy from the table above, it is 0.4, and for FS7, which is W2GK, it is one long edge discontinuous, and from the table we can use the value for beta Vy, which is 0.36, and for FS9, the value, the type of position for slab is one short discontinuous, and the value is 0.36 for beta Vy, and the value for GK and QK for each slab, as you can see here. For W1 GK, we get the 3.2 kilonewton per meter, and for QK we get 2.4 kilonewton per meter. For W2 GK, we get the answer is 2.66, and for QK is 2 kilonewton per meter. Same with action on slab for FS9. Okay, for action on beam, we use the dimension of slab to find the value for beam safe weight, and the value for beam safe weight is 1.78 kilonewton per meter. For our project, we have two span for slab, for continuous beam, and it is a span AC and span CA. So we find the value for permanent action and variable action for each span, and the value for each span, as you can see here. For permanent action for span AC, we get 7.44 kilonewton per meter, and for variable action we get 4.4 kilonewton per meter. And for span ACA, the permanent action GK, we get 7.64 kilonewton per meter, and for variable action QK, we get same with AC, 4.4 kilonewton per meter. The table here show that we have three cases of load that we need to calculate. So there is a value for every case. Okay, next we calculate the moment of inertia, and the value for inertia is 2.7 times 10 power of 9 millimeter power of 4. And we also calculate the stiffness K for AC and CE, and the value for every stiffness, as you can see here. And next we find the value for distribution factor DF for each joint, and we have three joint A, joint C, and joint E. For joint A and joint E, the value for the distribution factor is 1, because we assume that it is a fixed support beam. And for joint C, the value for distribution factor CA and CE is 0.43 and 0.57 respectively. And here the table of method distribution for load case 1. And then we find the fixed end moment, and the value for each of these fixed end moment FEM, we can draw a SFD and BMD, as you can see here. Okay, this is a table for method distribution for load case 2. As you can see that the end moment for member of CA is 17.79, and the value for member CE, which is minus 11.78. And also the diagram for load case 2, as you can see here. And then the last one we calculate for load case 3, and this is a method distribution for case 3. And the end moment for member of CA, it is 21.91, and for CE is minus 26.4. And here also we draw a SFD and BMD, and the calculation for span AC and span CE. Okay, where the last one is SFD and BMD envelope. As you can see here, we draw all the SFD for every case from case 1 and case 3. I think that's all from me. Thank you.
Assalamualaikum and hi, my name is Nuriana binti Jaafar. So I'm going to present to you the calculation for simply supported beam GB1. So first of all, we have to find the specification of the ground beam, and we refer to the Euro codes and British standard for the values. So we have to find the characteristic actions, the material, the diameter bars and links, the size, and also the durability, fire and bond requirements. So next is the main reinforcement. From the calculation of design bending moment, we could find the K value. The K value here is used for deciding whether the structures are required for compression reinforcement or not. So in this design, you can see the K value is smaller than K bell, so there is no need for compression reinforcement. Then from the area of tension steel, we can decide the number of bars used for the ground beam. So for this design, we use 7H12, and also the links for the beams is H6 and H10. Next point is deflection. From the equation that you can see here in the slide, the value could be used to find the allowable span or the actual span effective for the ground beam. So from this calculation, you can say that the actual span is okay. The span is okay and acceptable. Next one is for cracking and detailing. As you can see from the calculation, the steel could manage stress 229.58 Newton per millimeter squared. And from the slide, you can see also the detailing for ground beam 1 for this design, and also the spacing, the bar spacing for the beam.
Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. My name is Tenem Mustafa. So I will continue to present the calculation of continuous beam. So in our plan, we choose GB3 as our continuous beam. Okay, first for the specification, the effective span is 3.85 meter. The characteristic action, first permanent action, GK is 15.08 kilonewton per meter. Second one is variable action, QK is 8.8 kilonewton per meter. The next design life is 50 years. Fire resistant R90, exposure classes HCI. Materials, characteristic strength of concrete, FCK is 30 Newton per millimeter square. Characteristic strength of steel, FIK is 500 Newton millimeter square. Characteristic strength of link FRK is 500 Newton per millimeter square. Unit weight of reinforced concrete is 25 kilonewton per meter square. So our assume for bar 1 is 25 millimeters for tension. Second is 12 millimeter for compression, and the link is 10 millimeter. Okay, next for the durability, fire and bond requirements. So for the main concrete convert regard to bond, CMB is 10 millimeter. Main concrete cover regard to durability is CMINDO is 15 millimeter. Mean required assist distance for R90 fire resistant. Okay, so we calculate the mean required assist distance for R90 fire resistant. We got, so ASD we got 35. Mean concrete cover regard to fire, CMIN we got 19 millimeter. And then allowance in design for deviation, CDEF is 10 millimeter. Okay, next nominal cover, CNOM is 29 millimeter. Okay, for the third part is loading of analysis. The first one is characteristic permanent action. GK is 15.08 kN. Characteristic variable action QK is 8.8 kN. So our QK is less than GK. Okay, the design action WD is, we calculate and we got 33.56 kilonewton per meter, 56 kilonewton per meter. And the design moment we calculate for two is span and support. For span we got 44.77 kilonewton meter, and for support we got 54.72 kilonewton meter. So for the shear force at the outer support we got 41.37 kilonewton, and in the support we got 57.92 kilonewton. Okay, for the fourth part is main reinforcement, that is flexural design. So first one is 4D is 548.5 millimeter. D prime is we got 13 millimeter. And next flexure in span for design bending moment we is 44.77, and K, and we calculate K and we got the value of K is 0.033. Next for redistribution is 0%, redistribution ratio is 1.0, and for K-bell is 0.167, and our K is less than K-bell, so the compression reinforcement is not required. Okay, next we calculate the Z we get 532.04. Okay, next we got the area of compression steel. The area is 798.51 millimeter square, and then we try 2H10, we did 157 millimeter square. So we check cracking, check spacing. So spacing of outer bars, we got the total of S is 20 millimeter. Next, sorry, you can see. So next, the steel stress is 229 meter, 229.57 MPa. Okay, next we check for deflection. For the row is 0, we got 0.001. Row node we got 0.006. Row prime we got 0. And factor for structural system, K is 0.033. Next, P node is more than row node is more than row. So we use equation 1 to calculate, and we got 5.09. Okay, so the maximum span is 55837.3 is more than 3850 millimeter. So it is okay. Next is flat saddle support. Our design bending moment is it is same like before, is 0.003. The redistribution also same, the redistribution ratio also same, and cable also same. So our compression reinforcement is not required because our K is less than cable. Okay, so we calculate the area of tension steel, and then we try for we got 193. At the area we got 193.44 millimeter square, and then we try for 7 heat sheet, that is 198 millimeter square. So we check the reflection and the maximum span, and then we got that the value is 44209.1 is more than 3850 millimeter. So it is assumed as okay. Okay, next for the fifth part is shear reinforcement. The first one is support B, the critical support. So shear of central support is 57.92 kN, and the VED is 37 kN. The max shear resistance, and then we calculate the VRD max. So we got VRD max is bigger than VED, so it is okay. Next, the shear reinforcement. For shear reinforcement, we got 0.96, and the max spacing S we got 411.38 millimeter. So for the minimal links, we got 0.131. For the support A and C, shear of center support is 57.92 kN. VED we got 20.45. Then by inspection, shear reinforcement required and got data. Then we calculate, and then we got 0.038. Use the formula, calculate, and we got 0.038. Okay, the last one is detailing checks. So for the mean area, the value that we got is 0.76 millimeter square, more than 74.56 millimeter square. Okay, so next, for the settlement of main bar, for the first one, for the bottom curtail, we got 537.94 millimeter square, and we assume as 600 millimeter from A. And then for the top curtail, we got 537.94 millimeter, and we assume as 600 millimeter from A. And at support, we got 400 at the, and we got we use min to H16 as a 402 millimeter square as support A, B, and C. And then detail tab view bus tension lap with main steel is 480 millimeter, and we say at 450 millimeter. Okay, so this is the last part is our reinforcement details. Okay, so I think that's all from me. Thank you.
In conclusion, we could say that we have a better understanding on structural analysis and design subject. We already studied and gained so much knowledge that is very useful for us, the students, to apply it in the real life and for our career. And also, we were able to analyze the fundamental of buildings, and we can analyze, design, and find detailed reinforcement concrete according to the building design codes. And then for the overall result, you could say that our proposed design is considerably accepted because of the thorough calculation and checkings. And we were able to design this project through Dr. Suraya's guide. So we would like to thank you, Dr. Suraya. And then for the last point is teamwork. Everyone in the team, we collaborate and cooperate with each other. In the end, we get to achieve a fruitful result because of the members' creativity and their genius mind. So, as the representative for our group, we would like to thank Dr. Suraya for teaching us and for guiding us through this whole semester. And we hope we could see you again. So, thank you.